Alright y'all, today we're going to look at a review over tables, graphs, and equations to help you not only on your STAAR test or your end of year test, but also going into 8th grade next year. So we have 2 example problems that we want to help you guys out with. So we can also look at a table one as well, just to kind of help you guys out. But we'll probably do these 2 right now, and then I'm going to say we're going to do this one of these in class with you to help you guys out. So we want to make sure that you understand how to write and represent what are called linear relationships from both tables, graphs, and equations. So we're going to focus on these 2 in this video, and then double check with your teachers. We'll make sure that we go over one of the table ones with you in class. Okay, so for time purposes, I want to make sure we understand how to do this. So let's look. Time purposes, I mean, let's just look at these 2. All right, so on this first example, it says Skylar and Sophia are saving up their money to go to a ballet. They already have $50 saved and will save $10 each day until they reach their goal of $150. Which equation could be used to determine X, the number of days they will need to meet their goal? So let's talk about a few things here. If we're looking for your variable X, that's my unknown. And this goes with your number of days. And you can see right here, $10 each day. So when we talked about unit rate words, those were each, every, per, a, or an. Okay, so each, every, word, per, an. Every, per, a, an. Your unit rate words are always going to go in front of your variable. So $10 each day. So that means $10 times the days. And if you think about it, it makes sense. If we knew that they were saving for 3 days, well, 10 times 3 is 30. But we don't know how many days they're looking at. We have that X. That's why that's my unknown, my variable. If it says they already have, that's a key phrase for the money that they already have. So that's just your constant. Well, if they're saving $10 per day, are we going to be adding, subtracting, multiplying, or dividing with that 50? Let's think about it. They're trying to get to a total amount. So $10 times how many days they're saving. You already have that amount, so you're going to add it. So already has the key word for that constant. And we're trying to get to a total, let's see, of reach their goal of $150. So however much they spend or they save each day, $10 each day, plus their goal of 50 equals 150. That's the equation we want to look for. And we see that right here in answer choice B. Letter A is wrong because the X represents the number of days. This was saying if they would save $50 per day and they started with 10. Letters C and D are wrong because we're not subtracting. If we're getting a total amount of money, we're going to be adding it. We would be subtracting it if maybe they were saving $10 per day and then they owed a flat time rate, a fee of $50. Okay? Or they are saving $50 per day and they owed that one-time fee of $50. Okay? That's what you got to be careful of looking at. So there is on your interactive notebook a page of notes where we talked about that with our unit rate words. And you can double check your teacher where you might be able to find that in those notes for you. Okay? Let's keep going. It says, which equation best represents the relationship between X and Y in the graph? So what we need to do for each of these is we need to create a table. So we're going to look at our equations and we're going to substitute a value in for X to see what our input is, to see what our Y or our output is. So if we look at this graph, let's see what we can see from here. Sorry, it's a little blurry. Let me just kind of clear that up. Let's see what we got. All right, so this is answer choice A. Answer choice A says Y equals 2X minus 1. So we need to create a table with these ordered pairs. So what I like to do is make my little table over here. So let's say when X is 0, maybe when X is 2, you want to try 3 points, and maybe when X is -1. We can kind of change it up, okay? And we may need to do all of these, or we may be able to check the graph each time and cross one of them out, because they all have to be true. So in order for this linear relationship to match the equation, they have to be true for the points that we check. All right, so let's substitute in. When x is 0, we're just taking these x values and we're substituting in where we see x to our equation. Then we follow order of operations, parentheses or grouping symbols first, then exponents, then multiply and divide from left to right, then add, subtract from left to right. So we take the x value and substitute in for 0. We have to multiply first. 2 times 0 is 0, and bring down the minus 1. Well, if you have 0, you can't technically take away anything, but remember when you see subtraction, we add a line and change the next sign. So if you have nothing and you add a negative 1, then that means you have negative 1. Or 0 minus 1, just think about that means you're going 1 to the left. So in order for this equation to work, when x is 0, y has to be negative 1. So let's check it out in the graph. When x is 0, y is actually positive 1. So I can actually stop right there and say I know that it's not a. I know that it's not a because according to this picture, when x is 0, y has to be positive 1. But using this equation with my math, when x was 0, y was negative 1. So we can get rid of answer choice A. All right, so no reason in checking these other two when we know that that first one didn't work. Let's try answer choice B. All right, so answer choice B says y equals 2x plus 1. Well, stop and think about it. We already know when x is 0, y is 1, so let's check that out. See if that works. So we're going to take our x value and substitute right there. So 2 times 0 plus 1. Again, order of operations. Our grouping symbols, we do see parentheses, but there's no math to do inside them. There's no exponents. So we're going to go to multiply and divide. 2 times 0 is 0. Bring down the plus 1. If you have 0 and you add 1 to it, you get 1. That actually checks out. But we can't stop there. We need to try a couple of other, a couple more ordered pairs. So the good rule is to try and do 3. Okay? So we know that when x is 0, y is 1. Both on my graph and on the table. So let's try when x is 2. So 2x plus 1, I start with my equation. I'm going to take that value of x and substitute it. When I see x now, I'm going to say, okay, well, what's y when x is 2? So multiply first. 2 times 2 is 4, and 4 plus 1 is 5. So that means I'm looking for the ordered pair when x is 2, y is 5. So let's look at the graph. When x is 2, y is 5. So far, so good. So let's prove one more. So we tried 0. We tried a positive. Let's try negative. Let's try that negative 1 like we were going to do over here. So let's try it out. So y equals 2x plus 1. So now we're saying what's the value of y when x is negative 1? So 2 times negative 1, positive times a negative is a negative. Then you do the math like normal. 2 times 1 is 2. And then bring down the plus 1. Well, if you have two negatives and you add a positive, this would create a 0 pair and cancel out. So now you have one negative. Remember, when the signs are opposite when you're combining integers, so you have a negative and a positive, you actually subtract. So 2 minus 1 is 1. And you take who there are more of or who has a higher absolute value, which were the negatives. Okay, the negative 2, has a higher absolute value because you're 2 steps away from 0. Positive 1 is only 1 step away from 0. Or you can think of who you see more of. So when x is negative 1, y is negative 1. And let's check the graph. When x is negative 1, y is negative 1. Yep, this is going to be the one that works. So you could actually go through all these ordered pairs. Check it out. When x was 1, well, if I take 1 and substitute that there, 2 times 1 is 2. 2 plus 1 is 3. When x is 1, y is 3. If I looked over here, when x is negative 4, 2 times negative 4 is negative 8. Negative 8 plus 1 is negative 7, and that's where it ends up. So these ordered pairs would all match up according to that equation. All right, guys, thanks for tuning in. And as always, if you have questions, please let your teachers know, and good luck.